For this session, we are going to talk about selective routing and high availability. As usual, I have the protocol sniffing and then domain-based routing from the last session. I'm going to remove that, but I will keep two outbound that I have, and for selecting one of them as a default one. So a kind of selection, bit manual selection, that which one should be the default one. But before doing so, before testing the configuration and somehow sandbox way of handling that, I want to talk about the high availability part, because there is a misunderstanding of what a forward proxy can do and what a load, because many people confuse the high availability with load balancing. They are close in some conditions, but we are going to clarify that. While it's possible to have load balancing with a forward proxy, but a forward proxy hasn't been meant to do load balancing, and the reason is simple. If you have been working with browsers like Tor, you know every 5 minutes you're changing, or Tor browser changes your IP address. So 5 minutes now you're in Germany, 5 minutes later you're in France, and another 5 minutes you are, for example, in Canada. And for many websites, this is suspicious, because they think you can't be after 5 minutes from French to Germany or Germany to Canada. I mean, probably they block you. This is a kind of switching into a browser, but the load balancing, if we lower the time of balancing, which is a kind of distribution, we have the same result. Because if we balance the load between three endpoints, every time I have different IPs, which is again suspicious comparing to the if we look at the perspective of a endpoint backend. For example, I'm connecting to Instagram or I'm connecting to YouTube. They get suspicious of us if they see our IPs keep going to be changed. So that's the reason that for forward proxies, I mean for a good design of a forward proxy, high availability is useful, but we do not need load balancing. And load balancing specifically has been designed for reverse proxies, and that's the reason, for example, that if you look at HR proxy, the algorithms that we have in load balancing are really good and perfect. But one of the algorithm in in load balancing is the least response time, which these reverse proxies, you can see they don't have it. I mean, none of these have a least response time, but other forward proxies they have. H2 doesn't have, but these they have least response time, which means they care about availability, not load balancing. And the reverse proxies, you can see here, they care about availability, but it's through distributing the load to endpoints that we have. Let me show you what it is for the purpose. We have a user. Let's first talk about the forward proxy. If a user wants to connect, for example, to, let me change this to different location, for example. So location. If a user wants to, this is the whole thing that happens. A user connects to a proxy, and proxy forwarded to a specific location. But if a user wants to have multiple location, then this proxy that we have in between has to make a decision in order to route traffic to which one. This is the case that we have the availability for this person to select, for example, location A or location B or location C. Also, in availability, high availability perspective, if this server goes down for any reason, we can route traffic to this one, either manual or automatic, it doesn't matter. But in terms of in a user perspective, if a server goes down, I want to access another server. So high availability makes sense in a forward proxy, but distribution, like the request goes to all of these endpoints, I mean every 5 minutes or every 2 minutes, or keep request for every single request be loaded to these three servers, it doesn't make sense really. So that's the reason high availability is useful for a forward proxy, but distribution can be done, but kind of suspicious we get from the endpoint that we connect to. On the other side, if we look at, for example, a proxy, copy a proxy, when a user connects to a proxy, they don't care about the somehow suspicious of the endpoint, because we have application here and we don't care about the result of our request. So we have multiple application, and if a proxy somehow loads the traffic to just one application, these are idle and doesn't do anything. While for CPU and memory and all utilization, it's better to load traffic to all the applications that we have. So distributing load from a reverse proxy perspective is really useful and important, while distributing load from a forward proxy doesn't make sense so much. So for a forward proxy, we have to just select one route or one outbound. If we speak in singbox language, only one is required. So forward proxy, high availability are useful. And in terms of the reverse proxies, the distribution of load, the load balancing is important. While I should note that when we have load balancing, by load balancing automatically we have the high availability as well, because when we replicate we have high availability. If this app goes down for any reason, other two are available, so we can still load between them. So by having load balancing, we achieve high availability as well. But by having high availability, we do not need load balancing, and that's the whole point in forward proxies. Again, it doesn't mean that we can't implement load balancing, because as long as I know X-Ray has load balancing as well. It has the least response time for selecting the best, for example, candidate, but also it has the algorithm for load balancing between the endpoint or the servers that X-Ray wants to connect to. So let's go back and see our configuration. We have two outbounds and we want to select, for example, which one be the default one. This is not like the domain-based routing we were talking about, because in domain-based routing we select a specific domain that should go to a specific outbound. Here we are talking about the whole outbound, the default outbound. Everything should go to that outbound, and one of them stays idle. It doesn't do anything unless we select to do that. And singbox has that. Let's go to the outbound, and we have two important outbounds. One of them is selector or select. The other one, which we'll be talking about in the next video, is the URL test or auto for selection, auto routing. So let's go to the select one. The select one says type is selector, the tag is select. We can specify array of outbounds, and then the default one between these arrays that we have, which one, and also interrupt exist connection, which means if I switch the old connection, for example, if I switch from proxy A to proxy B, if there is a connection still to proxy A, should I stop that connection or no? So let's copy that. And let's go back to our configuration. And we know that if we put something here as the first outbound, it becomes the default one. So type is selector. We can change the name, for example, to whatever we want, but we keep it select. And the proxy that we have is hy21, hy22. We do not need the comma. The default is, this is the select one. We are going to select the default one when we run the application. So I select the hy22. Interrupt the existing connection, false. So let's test it. And we have no, like for example, the domain-based routing or something like that. Even we do not need this uh, interface selection. Let's go back. Let's run that. So domain-based routing, no. Selective routing for high availability. Let's run that. Actually requires my password for the root, and then let's run our server as well, the first one and the second one, and let's request to ip.me, the HTTP one, and to see which one it goes to. It goes to the second one. Why it goes to the second one? Because we have selected the HY2, the second one should be the default. Let's change that to 1. Run it again. It should go to the first one, this one, and it goes to this one. So this is the both. As a user, I'm going to select which endpoint I want to connect to, probably for geolocation, for whatever it is. But in availability perspective, when one of these servers, for example, if this one is not available for any reason, let's close that. It doesn't work. So as a user, I simply switch to 2 and rerun the application again. And then I'm back online. I can access the, for example, whatever the endpoint is. And probably if you think that's tedious, that if the server is not available, I stop my VPN and opening a configuration and then changing the location to another one, yes, it's kind of not desirable for many users and client actually. But we will learn that we can dynamically change that without stopping the sandbox or the proxy or the client with API, because this features, the first one, which is selection, and the second one is the auto selection, is based on the Clash one, and we have Clash API. If we enable Clash API, dynamically we can switch between location without stopping the client. And it is really simple and easy. We will see in upcoming modules talking about API management and user management for Sandbox. But we should know that we can have availability, manual selection, a kind of selecting between locations for both high availabilities or changing location according to a user need or desire. That's it. Thank you for watching. Anywhere you are seeing the video, please share your comment or thought. Also, we have Telegram group TonTab and repository on GitHub TonTab to share this configuration and also discussion about the Linux networking and security. Let's continue, go to next video.